Okay, how to rotate an n by n matrix in place. First, I should mention that I am still a student going for my bachelor's degree in computer science, so I am not a professional yet. I'm mostly making these series of tutorials for myself, so I can go back and reference them, see how I solve these problems, and if this helps somebody else, well, fantastic. So how to rotate an n by n matrix, so either a 2 by 2 or 3 by 3, a square matrix, in place. So how to do it without just creating a new matrix. So so what do we mean by rotate? Well, I'm going to rotate it 90 degrees. So I'm going to take this matrix, I'm going to turn it 90 degrees, and it's going to look like this. And this is a 2 by 2 matrix. This is a 3 by 3 and what it looks like rotated. Here is a 4 by 4, and if you rotate it, it looks like this. So this is what they look like. And when I was originally trying to solve the problem, I started with a 5 by 5 matrix, and I kept failing. I didn't get it right, so I had to go all the way down to a 2 by 2, and then I solved that. Then I went to a 3 by 3 and solved it, then a 4 by 4, and I tried to find the pattern. So that's how we're going to go ahead and do this. And I noticed that I can do it with a series of swaps. So with this 2 by 2, if I swap the top left with the top right, the top left with the bottom right, and the top left with the bottom left, then the matrix is rotated. If I use that same pattern, so with the 3 by 3, top left with the top right, top left with the bottom right, and top left with the bottom left, then the four corners are done. And if I move to the next element in a clockwise fashion, the top with the right, the top with the bottom, the top with the left, and the matrix is rotated. Now for the next matrix, the 4 by 4. If you notice with the first two, we only had to rotate the outside. We never had to move to an inside row. So for I guess row is probably not the correct word, but we never had to move inside the matrix. So for this matrix, how it's big enough that we'll actually have to go the inside, we will call the outside level 0, and we'll call the inside level 1. So we just do our series of swaps, move to the next element, do our swaps, move to the next element, do our swaps, and the whole outside is done now. And the inside works exactly the same as the outside did. So we just swap the top left with the top right on the inside, top left with the bottom right on the inside, top left with the bottom left on the inside, and the matrix is rotated. So now we see that we can do it with a series of swaps. So first, let's go ahead and label everything so we know which element is which. And I needed to get some information about the matrices. So like the first one, matrix size 2 is a size 2 because it's a 2 by 2. This is 3 by 3, matrix size 4 because it's a 4 by 4. Total number of levels 1 because we only have the one level. 1 because we only have the one level that we're actually manipulating. And over here this has total of 2 levels, the outside level and the inside level. The last element location for the 2 by 2 is 1 because 0, 0, 0, 1, 1 is the last column. Last element location is 2 because 2 is the last column. 4 by 4 matrix, the last element location is 3 because 3 is the last column. It's pretty much whatever the matrix size is minus 1. So doing our series of swaps, we'll swap now that we have these actual coordinates 0, 0 with 0, 1. We'll swap 0, 0 with 1, 1. And we'll swap 0, 0 with 1, 0. And the matrix is rotated. So we'll go ahead and we'll do the same thing for the 3 by 3. We'll swap the corners. We'll go to the next element, do our swaps, and the matrix is rotated. We'll do the same with the 4 by 4, swap the corners, go to the next element, do our swaps, go to the next element, do our swaps. The outside is done, so now we'll go to level 1, and we'll do our swaps, and the matrix is now rotated. So obviously we're going to have some kind of loops going on here to solve this. So let's go ahead and get our for loop started. I equals 0. I is less than last. The last element here is 1, so the loop will go through once. Here the last element is 2, so the loop will go through 2 times. Here the last element is 3, the loop will go through 3 times. Then when we get to the inside level, I just made I equal question mark because when I first started this, I didn't know how exactly going to the inside level would work. I knew it would be pretty much be similar to the rest, but I knew it would just be a little bit different. So we'll leave I equals question mark and we will get there when we get there. So let's go ahead and start with the smallest that we can do, the 2 by 2 matrix. So I is equal to 0 because it's when we first start. Last is equal to 1. We'll do our first swap. The swap is 0, 0 with 0, 1. And since I is 0 and last is 1, we'll swap I with I last. The next one, swap 0, 0 with 1, 1. So we'll swap I with last last. And the final swap, we'll swap I with last I. We'll swap 0, 0 with 1, 0. So this is what it looks like if we go ahead and put some numbers in there. This is what it is, and it is good. Before we move any further, let's go ahead and start programming this. Move this guy over here, and let's get started. First, we need to let's go ahead and make our matrix, our matrix size. We'll do it this way. So this way we can easily go between a 2 by 2, a 3 by 3, or 4 by 4. So const matrix underscore size equals 2. We'll do 2 now because we're doing a 2 by 2. And of course it has no idea what's going on. Now it does. So const matrix size equals 2. Let's go ahead and make a matrix. Do an integer matrix because that is nice and easy. We'll just call it M. Let's go ahead and copy that. Make that quicker. There. So now M is a 2 by 2 matrix. And how are we going to create this? Well, we'll do nested for loops. So for int I equals 0, I is less than matrix size plus I. That's the outer loop. So now, and that outer loop, when you do nested for loops, is the rows. Now we'll do the inner loop, which will be the columns. For int j equals 0, j is less than matrix size plus j. And we're all going to, for doing numbers, we're going to need a way to increment those numbers. So we'll do int, we'll do counter, or we'll just call it count equals 0. So now we will say m boom I, which is the rows, mj, which is the columns, equals we can just do count plus, which means that first it will give the number, it will give what count is, and then it will increment count. And that should do it. That should make our matrix of whatever size we want. Let's go ahead and print this. Let's make a function to do that, so this will be easier as we go on. I thought about doing this all beforehand, having this all out, but then I figured it would be easiest, or it will be better if I do this as I talk about it. It might be easier for me to follow later. Hopefully it'll be easier for everybody else, or everybody's just bored because they know how to do functions and everything. We'll call you print matrix. So we're going to use you to print, and we are going to give you that's not what we're going to give you at all. That's what we'll give you. So we'll put that in here because printing and setting up the matrix is pretty much the same. But that's not what I was trying to do. This is what I'm trying to do. Matrix size, and we're not going to do that. What we're going to do is C out. Yeah, that should be about it. For now, we'll just put a space up in there. And that should do that. That'll print the column, and then it'll go to the next one. And now it'll go to the next one, and we should be good to test this. Out of date, yes. I would like to build it. Alright, so let's go ahead and move this over to this screen, and we built it all, but then we didn't tell the program, hey, why don't you show it to me? So now, I'm going to call you print matrix, and I will give you M. That should do it. 0, 1, 2, 3. Alright, there we go. So there's our matrix, 0, 1, 2, 3. Press any key to continue. Let's go ahead and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Original matrix. So now we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we know what the original matrix is, and then when we rotate the matrix, we'll put it underneath, and that will be helpful. Let's go ahead and make this bigger. There we go. Let's go ahead and actually kind of just make this the size. Yeah, that'll be better. More to see. So there, we have our matrix. So now what we want to do is rotate our matrix. Let's go ahead and put something down here. Not original matrix, that wouldn't make sense. And there, we'll just put a bunch of lines. Alright, original matrix, 0, 1, 2, 3. It's inside of a bunch of lines, should be good. So now we said that this is how we're going to rotate our matrix right here. So for and IONT and I equals 0. I is less than last, which we haven't defined what last is yet. Plus I. Alright, let's do that up here. So what is last? Well, we know that last is equal to matrix size minus 1. And we're going to do a series of swaps. We haven't made our swaps yet, but this should be easy. We will use the copy swap idiom. So void swap. Let's use the super fun and easy idiom. We'll make you I, and we'll make you J. So temp equals I equal J equal temp, and look how gorgeous that looks. So we can print our matrix, we can swap our matrix, we can swap individual elements. So let's go ahead and make this work. Swap, and we're doing 0, 0 with 0, 1. So how will this look? This will look like M boom boom with M boom boom boom. Alright, so 0, 0 with 0, 1. I could just put the actual numbers in there, but that's not how we're going to do it. No, it's not. We're going to do it like this. Get you back over here. Alright, so I0, move you over here. We'll swap 0 with last, copy that guy. And here swap II with last. And here we will swap II with last I. Alright. So there is what we've come up with, how we're going to go ahead and rotate the 2x2 matrix, because that's all we've done. Now let's print this guy out. Actually, you know what? Let's go ahead and put that space in here, just because I think it'll look better with the space there. Print M. Alright, let's see what this looks like. That looks correct, only this shouldn't say original matrix, this should say rotated matrix. Let's look at it again. Yes, I would like to build it. Move you over here. So original 0, 1, 2, 3, when it's rotated, it will look like 0, 1 over here, 2, 3 over there, and it works. We did good. Alright, so back over here. We figured out the 2x2 matrix. Now let's move on to the 3x3. So we'll move on over here. I is still 0, last is now 2. And let's see if everything we came up before still holds true for the 3x3 matrix. So we'll put in numbers for everything. Everything looks good for the first loop. So now I will be incremented to 1, and we'll put numbers for everything. And if you notice, now things are not looking good. What's going on is all these numbers right here, they do not match up. So what worked for the 2x2 matrix didn't exactly work for the 3x3. We have to see if we can do things a little bit better. So one thing that we notice, if we go ahead and make these back like they should be, instead of using numbers, that if we look at the whole left side, I noticed is level 0, including this one over here. I should have marked it in this color over here, made that colorful thing, but I forgot. So all these throughout both loops stay 0, and they're level. So I should be able to go ahead and make those level, and that part should work. Now as far as this over here not working, it was last. Over here it is 2, which is last, but then over here it's 1. So I could just make last minus I, because 2 minus 0 is still 2. Over here 2 minus 1 is 1, and that part should work. So now let's go ahead and see if what we did still works. We'll put in numbers for our first set. Everything works. Go on to the now I equals 1. Everything works. Alright, we did good. Let's go over here and let's test this. So now we're going to make this matrix size 3. We're going to make, how did we say we were going to do this? Let's go back over here. Move you back over here. Alright. So now instead of this being II, we're going to make this level, which I don't think we've defined, so we have to go ahead and define it in our program. And I last minus I. Over here, last minus I. And let's go ahead and have level be at 0. I could level equals 0. I could have just added do a comma level equals 0, but we'll do it this way, so hopefully it keeps everything very nice and visual and we see what's going on. So now 3x3 matrix, we have it looking exactly like, nope, this here should be level. And this is what we've come up with. We said this should work. Let's go ahead and run it. 3x3 matrix, 0, 1, 2, 3, 4, 5, 6, 7, 8. and we go ahead and rotate it 90 degrees, 0, 1, 2, 3, 4, 5, 6, 7, 8. Everything looks like it's working. Just because we can, let's go ahead and make this a 2 by 2 matrix and run it again. 0, 1, 2, 3, 0, 1, 2, 3. Everything looks good. Alright, so we made it. So now everything works for a 2 by 2 matrix. Everything works for a 3 by 3 matrix. Let's move on to a 4 by 4 matrix. Before we move on, let's just see if this works. Because this is how I did it. I just kept seeing if it worked, and every time it failed, I tried to find where it failed. Control F5, 4 by 4 matrix is most definitely not working. And also the spacing's a little off. We'll fix that. 0, 1, 2, 3, 4. This right here should be 5, 6, 7. It looks like the outside's working, but the inside isn't. But that is something we're going to look at. So let's deal with this spacing issue that we have right now. Go ahead and pull this up on my other screen. And so right now we have it work. The spacing works great if we're only dealing with single digits. So if Mij is a single digit letter or single digit number, then let's give it 1, 2, 3, 4, 5, 6. Let's give it 6 spaces. Else if our current number is less or is greater than 10 but less than 100, then we'll give it 5. So 1, 2, 3, 4, 5. And then else. We don't even need to do parentheses. We could just say M is, or missed our C out over here. So if our current element in the matrix, which would be Ij, or well, if it's less, so now it's if it's over 100. So we will, yeah, we don't even need to do that. We can just do this. We'll just do our C out, and we'll do 1, 2, 3. We did 6, 5. Nope, we'll do 4. Alright, so if our current element is less than 10, we'll give it 7 spaces. That's too many. We'll give it we'll take off 1 space on each. I like to have spaces, but not too many. So if our current element is less than 10, we'll give it 6 spaces. If it's less than 100 but greater than 10, it'll get 5. Otherwise, it'll get 4. Looks right. Let's go ahead and see what this looks like. Oh, that is gorgeous. So this is a 4 by 4 matrix. 0, 1, 2, 3, 0, 1, 2, 3. That's right. 4, 5, 6, 7 for wrong, 7. So we can see the outsides are kind of looking like they're correct. So here's the rotated matrix, and the outside is correct. The inside is very much not correct. So our 4 by 4 matrix isn't working. Let's see why. Alright, so here we are. We're in our 4 by 4 matrix. We have I is equal to 0. Is less than last. Last is now 3. And for this very first level, let me go back here, everything works out. So then I is iterated to 1. And it looks like everything works out, which we would expect because the outside is going to work out correctly. So we move over here. I is now 2. And it looks good. Everything is working. Now we go over to level 1, which we haven't incremented the level at all, so now we have some work to do. So how are we going to do this? I is equal to question mark. Last is now 2 because we're in this inner loop, so now last is 2. So here's what we're going to do. We notice that when the level is 0, I starts at 0, level 0, I starts at 0, level 0, I starts at 0, level 1. If we make I start as 1, remember I is our blue, and so here if we make I 1 when it comes back, so if we increment it with the level, things seem to work there. So we have back to what it originally was. So this is what we're working with when we just finished with the 3x3 matrix. Let's go ahead and increment level, decrement last, because when we go to the inner loop, last is, or the inner level, last is no longer 3, it's now 2, it goes down by 1. And this is what it's looking like. We have it in a while loop. While we can say while the level is less than the total number of levels. So here level is 0, the total number of levels is 1, so the loop will happen once. Here the level is 0, the total number of levels is 1, so this thing will happen, then it'll be done. Over here, when we actually go into an inner level, the total number of levels is 2. We'll start at level 0. We'll go through the for loop 3 times. Then we'll increment level to 1. It'll come back through, go through once more. Let's go ahead and put some numbers in so this makes sense. So level is 0. I is 0 because I is equal to level. And we'll make last 3. So now we'll see if everything works when we put in actual numbers. It looks like for this first series of swaps, everything works. It looks like for this, when we increment I to 1, everything works. When we increment I to 2, everything works just like it did before. But now we're going to increment level and decrement last. So now level is 1, last is 2, so now I equals 1. Let's see if everything works, and it does not. We still have this problem over here with these two numbers. So let's see what's going on. Things didn't work. We get a big red X, we get a sad face, we get stormy clouds, we have things to figure out. Let's clear all those out of the way. Let's see what's going on. And this is the part that took me a little bit of time to see, but then I noticed if we go back to how things look when we're programming, we have last minus I, and last is 3, I is 0, 3 minus 0 is 3, 3 minus 1 is 2, 3 minus 2 is 1, everything works out. Over here last is 2, and I is now 1, 2 minus 1 is 1. So after looking at this for a little while, I figured out if we just go ahead and add whatever level we're in. So 3 minus 0 plus 0 is 3. 3 minus 1 plus 0 is 2. 3 minus 2 plus 0 is 1. That all works out. Over here, 2 minus 1 plus 1 is 2. So that seemed to work out. If we look over here, since level is 0, adding level doesn't matter. So we'll go ahead and make last minus I plus level. And this should leave everything the same as it was before until we go to level 1. And things should work. Let's go ahead and check it out. Oh, that's the end of that. Let's go ahead and bring this over here. There we go. Bring this other guy back. If I can find him on my other screen and bring him. There he is. So this is what we're working with. Went ahead and changed the size on me. So we're saying we need to go ahead and make ourselves a while loop. Go ahead and copy this guy right here. Put him inside our while loop. We'll increment level. We'll decrement last. And we'll make this last minus I plus level. make this last minus I plus level. And we're doing while level is less than total number of levels, which once again, that is something we haven't defined yet. We'll go ahead and have to do that. Level is less than tot num of levels. So how do we know if we have a 3x3 matrix, a 4x4, a 5x5, how many levels will be inside of the matrix? Well, we won't go run through it here, but I found out when I drew them all out that all you have to do is int tot num of levels equals is you take the total size of the matrix, you divide by 2, and since we're doing division in C++, that will give you however many levels that you'll actually be working with. So here we only have the one level, and it's a 2 by 2. 2 divided by 2 is 1. Here it's a 3 by 3, so 3 divided by 2 when we're doing division in C++ is 1. And here we have 2 levels. 4 divided by 2 is 2. And then if you're curious, you can just keep going up to 5, 6 and seeing if all that works. That's what I did. I actually had a pretty good time playing with all that and figuring it out. I was very happy when it all came together. So this is what it looks like now. This is what we have. We're saying that for int I equals level, because that's the only way we can get the inside working. I is less than last. We increment I, while level is less than the total number of levels. We'll do our swaps, which is level I last, level I last, last minus I plus level, and then the last one, level I last minus I plus level, level. That's what we came up with. Now that I say it out loud, it kind of sounds like a hokey way and very cumbersome, but let's see if it works. Okay, so here is our matrix, and here's what it looks like, and it looks like everything is working out great. Just to make sure we didn't screw anything up, let's go ahead and look at a 3x3 matrix, which is just this right here. So if a 4x4 matrix works, a 3x3 should work, but we'll go ahead and take a look anyway to make sure. Move this out of the way. 0, 1, 2, 3, 4, 5, 6, 7, 8. Everything looks good. Let's go ahead and look at a 2x2 matrix. Uh, 0, 1, 2, 3, 0, 1, 2, 3. Everything looks good. Now let's see a 5x5 matrix. We know it works for a 2x2, a 3x3, and a 4x4. Let's look at a 5x5. Don't press the enter key, press shift F5. Alright, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 10, 11, 12, 13, 14, 15 through 19, 20 through 24. Now I'm starting to get excited because if it works with a 4x4 and a 5x5, it should work for a 6x6. Let's check it out. 0 through 5, 0 through 5, 6 through 11, 6 through 11, 12 through 17, 12 through 17. It's looking like everything's working the way it should. So this seems to be working all right. Let's go ahead and get crazy and look at a 10 by 10 matrix. 0 through 9, 0 through 9, 10 through 19, 10 through 19, 20 through 29, 20 through 29, and all the way down, 40 through 49, 50 through 59, 60 through 69, 70 through 79, 80 through 89, 90 through 99. Things are looking gorgeous. So everything works out. That is how I came up with the solution. I had to start really small, work my way up, and try to find the pattern. I hope if somebody is looking at this because they were trying and they weren't able to figure it out, that this helps them. If by any chance anybody's looking at this and you're already a professional, and you noticed something wrong with my approach, maybe I approached the problem wrong even though I got the right answer, please leave comments and let me know. Otherwise, hope everybody has a great day. Thanks.